So today we're on 4.6, completing the square. We're going to solve and rewrite functions by completing the square. The first two, before we actually get into completing the square, are just solving equations that have squares in them. So these first two is something that you guys learned in Algebra 1, but it's been a little while, so we're going to review it anyway. Whenever you're solving an equation, you want to get everything to the left in descending order. So notice there's a number on the right of each of these. We're going to subtract to continue. So I'm going to subtract 46 from both sides. Then when you look at this one, whenever there's something that has two terms in it, you want to see if both those terms are perfect squares, which they are. 4 is a perfect square, x squared is a perfect square, and so is 36. Notice also that there's no middle term, so the number that it adds up to in the middle is 0, which means the numbers have to be the same. Okay, so I'm going to, in my head, take the square root of 4x squared, which is 2x. And that's how I'm splitting. Let me move this over. So 2x times 2x would be 4x squared. The square root of 36 is 6. To have no middle terms, you need one of each sign. Okay, then what do we do to solve again? Set them equal to 0. So the rest of it's the same. So notice they're exactly the same factors. There's just no terms in the middle.
Question?
Yep.
Can't we do it the other way, like subtract 10 and then...
Yes. However, I'm going to do that one on the second one. Okay, so I was going to show you both just because they both work. 2x equals 6, x equals 3. For this one, 2x equals negative 6, equals 0 first. Subtract 6, x equals negative 3. Okay, so that's one way. The second one, I was going to show you the second way. If you only have one x term, you can just isolate that one. So on this one, instead of bringing everything to the left, I'm going to add 5 to the right. The only time you can't do this, though, is if there's two terms that have x's in them, then you have to do everything on the left. You might be able to factor something out or something like that, but you can't solve it with an x squared on one side and an x on the other. So for this one, we get 3x squared equals 30. Then what do you do?
Divide by 3.
Divide by 3. So we get x squared equals 10. Then what? Square root both sides. But how many answers do you have?
2. So
2.
Plus and minus.
It is plus or minus. So the reason I showed you the first one is that when you factor, you do get 2 answers. When you square root, many people forget the negative one. They just go, oh, it's square root of 10. So that's why I kind of dislike this second one a little bit, because a lot of people forget that second answer. So I'm square rooting both sides. X equals plus or minus square root 10. Do they take it to decimals on this one?
No.
Okay, so they're going to leave it just like that. This one would be a little bit harder in the square root form, or in the factoring form to do, don't you think? Because you'd go, I don't really know any factors of 10 that add up to nothing. Generally, you're going to get weird numbers like this, square root of 10, or square root of 9, or not square root of 9, but things that don't have perfect squares, you're going to get square roots of numbers. If it was listed the other way, here's what it would look like. I'm just going to kind of do this one sideways. Okay. Hi, did you get that done? Okay, thanks. So on this one, if you can read my sideways writing, notice how I took a 3 out I left it there, so if you divide by 3, sit it out in the front, it just means when you set things equal to 0, 3 doesn't equal 0, and it's not an answer. But when you look at the other part, you need factors of -10 that add up to 0. You just have to remember the numbers have to be the same. If you don't know factors of 10, it's always the square root of that number. So I just wanted to show it to you both ways so that you could see kind of what it would look like. Okay, let's go on to the second one. So for this one, which way would you like to do them? One where you square root both sides or one where you factor? Square root? Okay, we'll do both of these that way then. So on this one, I'm going to add 10 to both sides. So you get 35. You're going to divide by 7. X squared equals 5. And then what's my answer?
X plus or minus 5. I mean square root of 5.
Yep, plus or minus the square root of 5. So here we square root both sides. And remember, you get 2 answers. One is positive, one is negative. So much faster when you do it this way. It's just please don't forget that second answer. On the next one, we'll subtract 9 from both sides. Divide by 2. X squared equals 2. So we square root both sides, and you get plus or minus the square root of 2. So one was, or actually both of these weren't very nice answers, but it kind of is what it is. Okay, while designing a house, an architect used windows like the one shown here. It's on page 234. What are the dimensions of the window if it has 2,766 inches of glass? So let's take a look at that one quickly. Page 234. So we have one side that has X, that's the width of the window. The length is 2x. So when you think about putting that together, wouldn't it just be like the area of it? So all you really need to do is take x times 2x and set it equal to 2766. When you're looking at it, there's a little bit more that you have to do. So look at, it says step 1, find the area of the window. Step 1, area. Then it says find the area of the rectangular part is 2x times x, or 2x squared. We just did that. The area of the semicircular part, that's the part that I didn't do yet. So I didn't draw I'm going to draw it on the bottom. It looks funny, but that's okay. So here, if you look at the actual radius of this thing, if it's x across, the radius would be x over 2. That's where that x over 2 comes from. So I'm not quite ready to do this part. Let me erase that. Plus. We have a half circle. Pi times radius squared divided by 2. Oops. Semicircle. So with this part, it looks kind of funny. So you're going to have a 1/2 pi. I'm just rewriting that a little bit nicer. Pi over 2 is like 1/2 pi. The radius is x over 2. And we have to square that. So we have the area of the rectangular part, the area of the half circle part. And now we have to make it look a little bit better than it does right now. So here we have 2x squared. X over 2 times x over 2 would be like an x squared over 4, or 1/4 x squared. Looks funny. I'm going to simplify it a little bit more. One half times 1/4 would be 1/8. Pi x squared equals 2766. When you look at this one, notice how they get a really, really strange answer there. Look at step 2. It says solve for x. Can we make a number out of this? 1/8 pi? We can get a number there. So let's change that out. Because they're both x squareds, we can really put them together. So I'm going to add 2 plus 1/8 times pi. About 2.393. One-eighth times pi plus 2. Okay, so now I'm going to take 2766 divided by 2.393. And then square root both sides. $34-ish. And they have plus or minus 34. So when I take the square root, you actually get plus or minus 34. Can you have a negative 34 in length? So on this one, negative doesn't make sense. So no negative 34. Can't have negative length. And what were we looking for? Dimensions or something? Yep. So if you look at it, the width is x, the length is 2x. So width equals 34 inches. Length equals 34 times 2. So all you have to do is just plug them back in. Yeah, that's all we need. Now, they go into more detail. They say the semicircular top has a radius of 17. They didn't really ask us that, did they? They just said dimensions of the window. I guess we could put it in there if we wanted to. Radius equals 17. Because it's 34 all the way across, the radius would be halfway across. So for this one, when I think dimensions, I'm thinking more length than width. So I would have probably just forgotten to do that one, but I guess it is kind of a dimension there. So that one is just like the first ones, only it is a word problem. So let's look at this one. This is the first one that we've had that is just going to be kind of something that looks like we can factor it instead. So since we have an x squared term and an x term, let's bring the 25 to the left. Now, when you think of factors of negative 21 that add up to 4, do we have any of those? Wouldn't we go with plus 7 minus 3? Is that right? So when you're looking at this one, look at the problem 3 at the bottom of 234. Would we need to know any different on this one? Would you guys do it any different than we did before? When I'm looking at this one, I'm like, hey, if I can factor the way I already know how, why would I turn it into a completing the square question is my thing. So even though they show it a different way, I would certainly factor it because you're always going to choose factoring first regardless because that's the one that we learned first. So if you can do it that way, why change it up? So again, I would go like this. X plus 7, x minus 3, set them both equal to 0. So I get negative 7 and 3. Now, what the book is doing, I'm going to show it to you just so you can kind of see it and won't be confused. So they leave the 24 on the right, or the 25 on the right side. So they're like, oh, I want factors of 4 that add up to 4. That would be x plus 2 times x plus 2, which you can write it as x plus 2 squared. And then they're looking at it going, why don't we square root both sides, okay, to get rid of the squared? So we get plus or minus 5, because the square root of 25 is 5. And then I'm going to subtract 2. So we get negative 2 plus or minus 5, which looks funny, but you're going to have two different answers. One of them is going to be negative 2 plus 5, which is 3. We got that answer before. And the other would be x equals negative 2 minus 5, which gives you negative 7, which again we also got before. So if you recognize that the left side is already something that we can factor, you can do it that way as well. I would definitely have probably done this one the first way because I always check factoring first. But if they're asking you for writing it like that, at least you kind of know what they're doing. Okay, so I'm going to skip that got it question. Let's go to the completing the square part so that we have a little bit of time to work at the end. Completing the square is all about finding that last term that makes it a perfect square, if it isn't one already. So what you're looking to do is you look to see, do I have the last term? If you don't, you find it and you add it to both sides. And they're adding it to both sides and making it something squared. So it's easier to just do one than to show using the variables. Okay, now this one is a little bit different question too. What value completed the square for x squared minus 10x? So they're kind of getting you ready to do completing the square, but not actually having you do it yet. So on this one, x squared minus 10x. What they're looking at is if you need to find that last term, which we do, we need to fill in this like box right here. You're going to take the middle term and take half of it and then square it. So whatever number is with the x in the middle, take half of it. This time it would be a negative 5. Square that number and you get 25. Okay, so if I factor this one now, I would look at what are factors of 25 that add up to negative 10. Well, if you have factors of positive 25, you'd need 2 positives or 2 negatives. Since this one is negative in the middle, you're going to have 2 negatives. So this would actually be an x minus 5, x minus 5. And that's what we wanted, was to make it something that we can factor. So I would either put the 25 in there or the negative 5 squared. When I do them, I like to leave it as a negative 5 squared because it tells you what the factor is. You don't have to turn around and go, well, now I need factors of 25 that add up to negative 10. It kind of saves you a little step. So let's do one. What would complete the square on this one? X squared plus 6x plus what number? You take half of 6, which is how much? And square it. I leave it like that. Okay, so I would leave it 3 squared. If you put a 9 in there, it's totally okay. We don't have to complete the square yet. We're going to do that on the next one, but they're just asking you for the value. So if they actually ask you for the value, you can square it out. If you leave it 3 squared, I totally get it because it's just something that we're going to have to undo anyway. Okay, so let's do one. There are some steps, I'm assuming you might have written them down. You're going to rewrite the expression by getting all the terms to the left side in descending order. You're going to complete the square by adding the middle term divided by 2 and squaring it. You're going to factor it, find the square roots, and solve for x. And normally you probably just do it. You don't think of the number of steps involved to do it. What's the solution of this one? So when we look at it, I'm looking at that 3 at the beginning. I don't really like the 3. If you can take that 3 out, do it. So I'm going to take a 3 out at the beginning. Like that. Is the 2 like a perfect square? No. So a lot of times people will maybe leave that 6 on the other side right away and leave a space. That's probably what I would have done. So I'm going to go back just one step. I'm going to leave a space right here. Let me just start over. Hold on. So we know we're completing the square, so I'm going to move this one over. Okay. We need half the middle term and square it, but if you don't like that 3 there, you can take it out now. The 3 has nothing to do with the 6 on the other side, it's just on the left side. We're going to take half of the middle term and square it. Half of the middle term would be negative 2 squared. Oops. Whatever sign it is does go in the parentheses like that. I leave it negative 2 squared. The book probably doesn't. The reason I leave it like that is because the next step then is kind of already spelled out for you. We need to factor it. This is my factor, sign and everything. So I'm going to go x minus 2, x minus 2. Now, the only thing that I haven't done yet is add it to both sides. I wanted to kind of show you that this actually works first. The number that I need to add to the right side has to do with this number right here. How much is negative 2 squared? 4, right? Negative 2 times negative 2 is 4. What is 4 times 3? So I'm actually going to add 12 to the other side as well. So I'm adding 12 to the other side. If you wanted to, you could put 3 times negative 2 squared on the other side and kind of just do it on your calculator too. So this number isn't truly a negative 6. It is something else. I just hadn't done that step yet. It's a 6. Now here's where you've got a little bit of leeway as far as how you want to solve it. For me, I would divide by 3 first. Get it out of there. You could multiply it through, but that would take you a lot longer to do. So here's what we're looking at. We have 3 times x minus 2 squared equals 6. I'm going to divide by 3 first. I have x minus 2 squared equals 2. Now, I would probably do square root of both sides because it's kind of set up for us like that. Is that what you guys would do too? Everybody divide by or square root both sides? If you didn't, you'd have to FOIL it all out and then factor it. Yep.
That's what I was wondering what we would do.
Yeah, so let me show you one way here, and then we'll show you the other way on the other one. So let's square root both sides. And we are looking at x minus 2 equals plus or minus the square root of 2. X equals. They kind of gave you a goofy one to begin with. Yep, that's the answer, but I would have thought they would have given you a nicer one to begin with. Is that 2 answers? It is, right? One is 2 plus the square root of 2. The other is 2 minus the square root of 2. It's just that we did not necessarily go, all out to begin with. So let's look at another one. And then maybe I'll do the other way this time, just so you can kind of see it. If you look back in the book too, they pretty much do the same way that we did. And actually, when you almost have to do it that way. Because I'm thinking if you would have multiplied this thing out, you would have had x squared minus 4x plus 4. You'd have to undo the factoring that you've already done. So there isn't really another way to do this one. Okay, so let's look at this one. Can we factor it the way it is? Maybe. If you guys were factoring, you probably would go, okay, there's a 2 out front. I'm going to swing it to the right, correct? But on these, they do want you to use completing the square, so we're going to do that. So in completing the square, we never need this number. So let's get rid of it right away. So we have 2x squared minus x equals negative 3. And I left a space because we need to fill that in. I always put a plus there. The sign of the number is always the sign of the number that's inside the parenthesis. So I'm going to pull that number out. I have half of negative 1 and square it. So I'm adding a negative 1/2 squared to both sides. I didn't find out what the number was, but I could do that really, really fast. So with this one, I'm going to have a, and should we have taken that 2 out? I probably should have. Because if we don't, they're not going to be the same. I'm changing it just a little bit here. If I take a 2 out of -1, though, I get a fraction. Okay, I'm going to go back because it's making it too messy. I wasn't thinking about the 2 at the beginning. Okay, sorry about that. So let's do this. 2x squared. How do you take a 2 out of -1? Do you multiply? Do you divide? What do you do? Divide. So if you have a -1 there and you take if you divide by 2, you actually have -1/2. Is 2 times -1/2 -1? It is. So it's okay. It just looks bad. And then we still have our -3 on the left side. So instead of taking half of -1, we're taking half of -1/2. And on your calculator, you'd go -1/2 divided by 2, and it would give you a -1/4. Fractions are not really that fun to do. Now remember, the number we add to the other side has to include this 2 with it. So I'm adding 2 times -1/4 squared. You could multiply it out if you wanted to, but why? As long as you're going to grab your calculator anyways, you don't necessarily have to until the next step. So we have 2 times x minus 1/4 squared. And now on your calculator, you could go -3 plus 2 times -1/4. You could type it in probably exactly how you see it. I'm just going to sketch it out because I don't have my calculator right next to me. This would be 1/16 times 2 would be 1/8. That would be -2 7/8, 16. Is it -23/8? That looks like a weird number too. Somebody do this. Do -3 plus 1/8. And does it give you -23/8 or -2 7/8? Is that right? Okay. So again, it's an ugly fraction, but it is what it is. Now I would divide by 2. So I take my -23/8 and divide it by 2. And then the last step will square root both sides. So this would be -23/16. And then we'll square root both sides. Where do they have this one? Okay, I don't even know where I found this one. Got it, number 5. 2x squared. Okay, I forgot the second half. That's why it's turning out so weird. We'll just go with it. I changed it, but that's okay. X. I'll have to change it after this one. Okay, so you guys are probably not going to come up with any square roots of negative numbers because we haven't covered imaginary numbers yet, but at least you kind of saw how it came to the end. You'd probably have a number like 8 or something. So the last step would be to add 1/4 to both sides. This was supposed to have something over here. That's why it didn't work. Oops. So I'm going to keep it like this, but you will not have any answers like that are as weird as that one. let's go on to look at problem number 6. Notice they have some calculator stuff, but we're not going to do the calculator stuff this time. I just want to show you what they're doing. They're actually just checking with the calculator instead of actually doing it with the calculator. So let's do the question, and then we'll look at what they did on the calculator to solve that one. Okay, so when they're looking at vertex form, what does that look like as an answer? What we're trying to get in vertex form is like this, right here, kind of. Okay, so it's kind of like that form is kind of what we're shooting for. Only everything's going to be on one side, basically. So let's do this one. And then you guys get a little time. Very little, but a little bit of time to work. So with this one, notice they have a y equals x squared plus 4x minus 6. This time, since the numbers are on the things are on the right and the y is on the left, you don't want to add to both sides. So I wanted to show you this one for sure, just so you could see what you do when everything's on the same side. So we first ask ourselves, do we know factors of -6 that add up to -4? I think we probably do not. Okay, if we did, we would factor it. Okay, so always check factoring first. This time, it's just not an option. So what I'm going to do different on this one is this. I'm going to leave my space, and I'm just going to move that 6 over a bit. So remember how we added the same thing to both sides? Here, we're keeping it on the same side, so we're going to add, and we're also going to subtract. And this is like, I think, how you initially learned completing the square. The good thing about this one is we know what half of 4 is. It's 2. So we can add 2 squared to fill in this little blank that we did, and we can also subtract 2 squared just so that you keep it equal. So you have to do it to both sides regardless, but if it's on the same side, you add and you also subtract. So the vertex form comes really fast. Then we'd have a -6 minus 4, that'd be -10. So this is vertex form. Now you'd have to name the vertex and the y-intercept. So the vertex this time, is it 2, -10 or -2, -10? -2, -10. And then the y-intercept. How do you do y-intercepts again? What do you plug in for 0? The y part or the x part? The x part. So if we actually look at this thing and we put a 0 in there, then you'd figure out what do you get. So when we plug a 0 in there, we get 2 squared, which is 4. And what's 4 minus 10? -6. So the y-intercept this time would be -6. Look back at the beginning. Could we not have known that right away? If you plug a 0 in there and a 0 in there, don't you get -6? You can plug that in wherever you want to. Just make sure that if you're using that number at the end, I'd go back to the beginning because it's actually easier and faster than to figure it out at the end and do calculating in your head. Okay, so do you want one more of those since they're a little bit different? Are you good? You kind of went over these ahead of time, so I don't know what you need. Do you need one more, yes or no? Okay, if you need some help, just ask as you're going through it.